Section 5-4 is having you now divide polynomials, which is setting a groundwork for what you're going to be doing for later on in this unit. Basically what I'm going to have you guys be able to accomplish, and what you should be able to do by the end of this lesson, is be able to take any polynomial function, be able to divide it by any linear binomial. Okay? So what I want to do with these videos here is to set this up into two different layers here. Level 1 here, I just want to this video is just here to lay a groundwork for where synthetic division comes from and how we can use it. The rest of the videos here in the parts here for lesson 5-4 is me just rattling off a bunch of long synthetic division problems, just that way you can get a sense for how it works and get pretty comfortable with it. The moral of the story here of the overall picture here is I don't want us to get too comfortable with long division, just as I want you guys to get more comfortable with synthetic division, just that way it's a lot faster way of doing the division that you need to do to get to more important stuff. Okay, so I like how this textbook lays the foundation here for synthetic division by comparing long division with numerals with polynomial long division. Okay, so if you forgot how long division worked with numbers, take a look at this example here of taking 21 and dividing it into 672. In other words, 672 divided by 21. First step you do is say, well, 21 can't go into 6, but 21 can go into 67 3 times, right? And then what you did is you took the 3 and just the 3 and multiplied it by the 21, wrote the product right there. What they don't put there is that subtraction sign, right? So then you subtracted, got the 4, and then you brought down that 2 to make that 42. And then you repeated this process. 21 would go into 42 just 2 times. Now what did you do here? Didn't you only take the 2 and not the 32? You took 2 and multiplied by the 21 to get 42, and then you subtracted again. Got a remainder of 0. Here's what that means. Doesn't that mean that 21 is a factor of 672? Put this in perspective. Don't you already know that 5 is a factor of 25? Because if you divided the 2, you'd end up with a remainder of 0, right? So just showing you that with a smaller example, okay? Now, polynomial long division, same sitch, okay? Except they trim it down to just this part right about here and this part right here. If all I showed you, oops, make that rectangle a little bit smaller. If all we showed you here was 2x and 6x squared, wouldn't it be true that 3x times 2x would make 6x squared? And do you remember what we did back over here with that 3? We just took that 3 and multiplied it by 21. Well, we're going to take the 3x and multiply it, not just by the 2x, but we're going to multiply it by the 2x plus 1. That's where a little distributive property comes in. Boop, boop. So 3x times 2x plus 1, that's where we get the 6x squared plus 3x. Let's get rid of that other rectangle. And so now what we need to do is subtract these two. Once again, missing the subtraction sign. So let me drop that subtraction sign right there. Subtract those, that makes a big 0. 7x minus 3x makes 4x. You bring down that 2. Process repeats itself. 2x times 2 would give us 4x right there. Okay, so then we take just the 2, but not the 3x, but just the 2, and do distributive property again. That's where this guy comes from, this 4x plus 2. Subtract, get a remainder of 0. Okay, so just like we would say that 21 is a factor of 672, we would say that 2x plus 1 is a factor of 6x squared plus 7x plus 2, because the remainder is 0. Okay, so that leads to this remainder theorem here. If you divide and you get a remainder of 0, then it must be a factor. Okay? If you divide and you do not get a remainder of 0, that means that what do they call it, divisor, is not a factor of that polynomial. Okay? So that's laying the foundation there. Now, where synthetic division comes from, okay, is just a faster way of doing long division. So what I'm going to do for you right now is I'm going to do long division and synthetic division at the same time. Take a look. I'm going to do it with this problem here on the note sheet. Alright, so here's how this works. If we were to divide this using long division, what it would look like is we'd be taking x plus 2, division sign, and in there we'd have x to the third minus 14x squared plus 51x minus 54. Okay? That's the setup. Compare that to the setup for the synthetic division. Synthetic division, you put a little half of a box right there, and then you're going to put in a -2. Think about where that -2 comes from. Any ideas? Yep, that -2 is actually the opposite of this number right here. Why the opposite, you ask? I'll show you why in a minute. It's really quite genius. And I wish I'd come up with it myself, but maybe I should have taken credit for this. It's the first time you're probably seeing it, right? So maybe I should have claimed it. All right, but I won't. So that's where that comes from. That's the only place where you actually do the opposite. See this stuff all in here? Do you see the coefficients in front? You might not see that one, but once again, that's a 1 right there. So we write down those coefficients. 1, -14, a 51, and a -54. Okay? If we were doing this long division style, we'd be looking at two things and two things only. This guy and that guy. And we'd be looking at, hey, what do we need to multiply by to make that x become an x to the third? Hey, I know. I think we'd need x squared. So we would put in 1x squared right there, and then we would do distributive property and write its product right down below. X squared times x would make x to the third. X squared times 2 would make a positive 2x squared. Then we would have to subtract. And this is what bothers students here with long division, right? With long division, we'd have the x to the third minus the x to the third makes 0. We'd have -14x squared minus 2x squared. I can't tell you how much or how often I see students write this. See why that's a mistake? You don't. Maybe you do. Reason why that's a mistake, ladies and gentlemen, is because we are taking -14 and subtracting 2 from it. So -14 minus 2 would actually put us down to -16x squared. And then just like long division dictates, we would bring down that 51x. I'm going to pause here, now I'm going to bring it over here. With synthetic division, draw a line. Give yourself some space. And then, see how annoying that subtraction was and about that mistake that I was talking about? And that reversal of that +2 to a -2? Guess what that allows us to do? That allows us to put a plus sign here. And this brings us to your note sheet. Back to your note sheet. Do you notice right over here, as you're filling in these steps, do me a favor, please. Could you please put in plus signs here, here, here? Just to remind yourself that you're going to be adding here. Okay? Let's get back at it. So right here, we're going to bring down that 1. Reason why we bring down that 1 is because look underneath. I don't see anything underneath. So 1 plus nothing essentially is 1. Now I'm going to keep going on this side. What you do next is you multiply that -2, that number in the box, by any number that you get down there, and you put its product in the next column, the next consecutive column. So -2 times 1 would be -2. I'm going to drop a -2 right there. And now I am going to add those two together. So what's -14 plus -2? Isn't that -16? Pause right now and take a look. Take a look. Think there's a connection there? There is. Okay, we're on to something here. Back over to the long division. What we have done now is we've looked at that -16x squared and that x right there and said, hey, what do we need to multiply there to make that x become a -16x squared? I think we would need a -16x. So we'd write down a -16x, right? See the connection again. Once again, that's probably the biggest connection right there is why that 16 is there. See that? -16, -16. Coincidence? No, it's not. So then -16x, remember just this part, is going to happen with distributive property with that x plus 2. So when we do that, here comes a, let's see here, that would be -16x squared, and -16 times +2 would be -32x. And then once again, the subtraction move comes in. You can see the annoyance with the subtraction. It's so annoying to do the subtraction, right? And then here's where students get goofed up. Because of this subtraction and then that minus sign, aren't we essentially adding here? So wouldn't that make 83x? Yes? Yes, it would. And then we'd bring down that -54. We'd repeat the process. X times what would give us 83? Well, 83x. Wouldn't we just need a positive 83? Let's pause here and let's go back over here. when you get a number down here at the bottom, you multiply by that number in the box, in this case negative 2. Now that I have a negative 16 down there, let's multiply negative 2 times negative 16, we get positive 32. Hey, I put a number right there in the next column. Let's add those up. What do we get? Oh, look, 83. Okay. Then, what we do over here in the long division, I'll go back over to the long division here. We'd multiply 83, distributive property again. That would give us 83x, and then 83 times 2, oh boy, what's that? Oh yeah, that'd be a 166, a positive 166 right there. And then once again, annoyance, subtraction. That subtraction stuff gets rather annoying after a while. 83 minus 83, 83x minus 83x, gone. Negative 54 minus a 166, I think that's negative 220. Okay? Back over to synthetic division. We just brought an 83 down. Let's multiply it by a negative 2. Wouldn't that make negative 166? Let's add those up. We get negative 220. Okay? See that negative 220 that's right here? Wouldn't that be your remainder? Which would say that x plus 2, you're not a factor of this polynomial. So when you do synthetic division, you're going to put another little half box around that last number there. And that number there is your remainder. Okay? So when they ask us for a couple things here, they're going to ask us for the quotient and remainder. If we're doing this synthetically, here's your remainder. Now here's the beauty part about that quotient. That quotient, when you take a polynomial of degree 3, divide it by a polynomial of degree 1, that degree is going to drop down by 1 to an x squared. See that? It's a square. When you get these right here, that's the beauty part about writing this in order from highest degree to lowest degree, is what you're looking at right there is actually 1x squared, 1 degree less. What you're looking at right there, you're looking at there is a negative 16x, and then you're looking at just 83 with no x there. And then you have your remainder of negative 220. Okay, so there's synthetic division in a nutshell. It does the exact same thing that long division does. So I want to stop this video here, and then pretty much what you're going to see me do for on the next video in this playlist is a whole bunch of synthetic division, so that way you get the handle on how it kind of works.